Hi, my name is Valentin and today we'll be working with a diabetes dataset focusing on analyzing the glucose levels and other important features like age and blood pressure. Step 1, loading the dataset. The first thing we did was load the dataset using the Pandas library. This dataset contains various health-related attributes like pregnancies, glucose, blood pressure, skin thickness, BMI, diabetes, pedigree function, age, and outcome, where the outcome column indicates whether the person has diabetes. Why it's important? Loading the dataset is the foundational step that allows us to inspect and manipulate the data to gain insights. Step 2, analyzing the glucose column. We started our analysis by focusing on the glucose column. Specifically, we checked how many entries had a glucose value of 0, which is medically implausible, and calculated the percentage of these 0 values. Why it's important, understanding the distribution of glucose values is crucial because it's a significant indicator of diabetes. And then step 3, analyzing the age column. And here we explore the age column to find the youngest and oldest participants in the dataset. We also divided the age column into bins, to see the percentage distribution of different age groups. Age is another critical factor in diabetes risk. Grouping the age data helps us see which age ranges are most represented. And step 4, which was visualizing pregnancies versus age. Here we created a scatter plot to visualize the relationship between age and pregnancies. This helps us understand how pregnancy frequency varies across different ages. Visualizations like scatter plots allow us to see trends in the relationships in the data that aren't immediately obvious from the raw numbers. And the fifth step was analyzing blood pressure. We analyze the blood pressure column by calculating its mean and median. This basically gives us an idea of the central tendency of blood pressure values in our dataset. Blood pressure is another key indicator of health, and its analysis can reveal trends or outliers that need further investigation. Step 6 was data processing. We selected the key features including glucose and used standard scaler to normalize the data. This step is crucial before training our machine learning model. Scaling ensures that all features contribute equally to the model, which improves its performance. And when it comes to splitting the data, we split the data into training and testing sets. The training set is used to train the model, while the test set values while a test set evaluates its performance. The split allows us to assess how well the model generalizes to new and seen data. And then logistic regression model. Here we use a logistic regression model to predict the outcome, whether a person has diabetes or not. After training the model, We evaluated its performance using accuracy scores and confusion metrics. Logistic regression is a powerful and interpretable model for binary classification tasks and like predicting diabetes. And the eighth step is this model evaluation. We evaluated our model's accuracy in both the training and testing datasets. We also looked at the confusion metrics, which show us how many true positives, true negatives, false positives, and false negatives. Evaluating the model helps us understand how well it's performing and whether it's making reliable predictions. Finally, we explored how different values of the regularization parameter C affect the model's accuracy. Regularization helps prevent overfitting by penalizing large coefficients. Regularization is key to improving the model's generalization ability, ensuring it performs well on data. Um, by the end of this analysis, I've learned how to process data, build and evaluate a machine learning model, and interpret its results. We found that the best model accuracy was achieved with a specific value of C for realizations. This project highlights the importance of data analysis in making informed decisions, especially in healthcare. Understanding the steps and the results in this analysis allows us to see how data-driven approaches can help in real-world applications such as predicting and managing diabetes. So let's run it, and then yeah, we got the results here. As you can include the charts and the graphs we created, like the scatter plot of pregnancies versus age, and the regularization um, plot. Thank you.